This is a report that just came out from the International Red Crescent, Red Cross, and United Nations Office of Coordinating Human Affairs, which just highlight some of the points about preparing for the heat waves of the future. Some of the messages are repeated, but from other podcasts, but that's okay. The main points: heat waves are a major cause of suffering and death. We already know that, but the increases in duration, intensity, and frequency of these heat waves and the area covered are, of course, of great concern for a country like Pakistan and India, for example, and China, which got hit with heat waves and then floods and droughts following that this summer in 2022. Heat waves prey on inequality. Their greatest impact are on vulnerable, isolated, and marginalized people. So there are ways to compute vulnerability indices, use that with the hazard like heat wave and exposure, which depends on population density and infrastructure and so on, and the responses to create risk maps. We'll look at one vulnerability map from Durban, South Africa, to get an example of how these are occurring at small scales, which makes the prediction challenge much more difficult. Climate change is already making heat waves much more dangerous, so observational historic period over the last several decades can be used to show the changes in duration, frequency, and intensity. Heat waves will become deadlier with every further increment of temperature rise associated with climate change. This is obvious. The most direct and predictable aspect of increased greenhouse gases due to human activities is the warming. The patterns are still important, and to remember the heat wave attribution we talked about from Geert van Olberg's paper. Models are right now good at predicting heat wave changes at a certain scale. The information needed is at very small scales where the models are still not good in terms of attribution. So we have to now find ways of using skillful forecasts at whatever scale they're available, and then use artificial intelligence, machine learning, and monitoring systems to produce information at local scales where they are needed for decisions. Extreme heat has cascading impacts, threatening non-human life and undermining the systems that keep people healthy and alive, which include everything from the animals we depend on for food, and also pollinators, vegetation species, and so on. That all species are being affected by these. To look at the historical period, here are the heat waves and deaths over 1960 to 2019. So the total number of deaths are shown with these circles, and the number of heat waves are shown here. So you can statistically show that there is an increase in the number of heat waves over the years, and the number of deaths depends. There is latitudinal dependence. A heat wave over Europe will create many more deaths than a heat wave over tropical countries, just because tropical countries people are used to heat waves, and biologically it's not clear whether they are better adjusted or genetically more prepared for dealing with it, but at least the data shows that there are mortality differences. Global mean temperature change by year, looking at 1961 to 2021. We are looking at the change with respect to a baseline. The 0 degree line is here, which is the baseline, and you can see that the 1960s we were already in the warmer than the baseline period, and you can see that as we have gotten into the 2020s now, the number of years breaking instrumental records for the warmest global temperature are increasing. I think the top 10 years or top 5 years have occurred in the last 6 or 7 years. Obviously natural variability is still there, so 2015-16 which broke the records, and then some cooling with La Nina happening, and then again new records being established, and so on. But if you look at the change in days of heat wave exposure relative to the 1986 to 2000 baseline in people older than 65, you are looking at USA in this darkish orange color, Japan in the lighter orange color, India in even lighter orange color Indonesia and China. And the message is clear that from the 1980s now we are definitely getting into year after year of increasing number of heat wave exposure relative to the baseline period for the rest of the world and for US, Japan, China, India, Indonesia, and so on. So you can see the scales here in terms of number of people per 100,000. I think that's how this is done. Sorry, this is change in days of heat wave exposure. Okay, so that's always bad news, especially for the elderly and the very young. Working hours lost to heat stress by subregion, looking at 1995 versus 2030. Obviously there are assumptions involved in making these projections, but nonetheless it's not something you can ignore in terms of planning for GDP losses, productivity losses, and the number of days of labor lost, etc. Okay, and to repeat the message, extreme weather effect on women is disproportionately high. So this is a pie chart displaying the findings of 53 studies. So it's a meta-analysis of published studies examining the rate of death and injury from extreme weather events. 32 found women were more likely than men to suffer death or injury from extreme weather. 12 concluded that men were more likely than women, and 6 found no gender difference. Rounding errors mean the proportions may not add up exactly to 100%, but clearly more than 60% of the studies concluded that women suffer disproportionately more, as the UN I think UNFCCC head Cristina Figueres used to say, climate is not gender neutral. But this also says how to reduce vulnerabilities by training women to use alerts and so on. And that comes down to looking at vulnerabilities and creating vulnerability maps literally at neighborhood level. So this is a heat vulnerability mapping in Durban, South Africa. Correlations between heat stress and social vulnerability. Social vulnerability index, there are many details that go into it that I have reported elsewhere in another podcast you can look up. Social vulnerability index by population density, very low in these lighter colors, low, medium, high, and very high. So you can see that combination of various factors like socioeconomics, education, women's education, especially per capita income, etc., create very contrasting vulnerabilities even within a city. And this is showing the urban heat island intensity within Durban. You can see that heat island intensity has population with higher social vulnerability indices, and this also is related to population density. So exposure, for example, to a heat wave very much is affected by population density, for example. Okay, and access to infrastructure, hospitals, schooling centers, etc. make a difference as well. So moderate and low heat island intensity. Heat island generally has this kind of typography, even though in India it is found that the use of rural areas for agriculture and leaving them barren after the rainy season can actually make the heat island effect worse in some rural areas than in urban regions. So one has to be careful about regional specificities of these typographies. So this is looking at late afternoon temperature in degrees centigrade. Rural is down here, suburban residential, which reduces vegetation, increases paved areas, and bouncing around of the infrared energy makes it worse. And then commercial and downtown regions, of course, get much worse, and then going back to urban residential areas, park areas, back to suburban residential areas, and rural farmlands. Just generally think about how urban heat island effects affect vulnerabilities and exposures and risks for heat wave mortalities. I'm not a huge fan of projections over to the later part of the 21st century, because here it's the uncertainties in the scenarios used to produce the projections that end up creating the unknowns in these projections. But nonetheless, looking at historical periods, you can see that percentage of land in Middle East and North Africa exposed to heat wave have been increasing for normal to moderate and severe to very extreme heat waves, and obviously they are expected to become super ultra extreme over time if things continue as they are. But the message still is that we have to improve forecasts, early warning systems, adaptation measures, and reduce vulnerability and risk overall, because hazards may not be in their control. It's a global dynamics that create these hazards. Obviously, that is shown here that the global south, the so-called global south, except for Australia, which is the global north, in other words, developing tropical countries and south eastern US, have number of days projected to exceed potentially deadly heat wave levels per year by 2100. So you can see this is in the range of 50 to 100, but as you get into South Central America, Central Africa, Eastern Africa, India, Southeast Asia, and Northern Australia, you get to number of days projected per year in terms of exceeding potentially deadly heat levels is alarmingly high. Even though there are uncertainties, one has to worry about these, especially because in the tropics, with ocean being so close here, these warm temperatures come with increased humidities, and as the dew point temperature drops, the human body's ability to get rid of heat by sweating is going to be curtailed severely. So the heat waves with high humidity can become deadly very, very quickly. So that has to be watched out for. These are incredibly warm, humid regions already, so further warming and exceeding potentially deadly heat levels is something that cannot be ignored, no matter what the uncertainties are in the projections. So we have to worry about the horizons, 2030 horizons, even if we don't worry about the 2100 horizons. Obviously, it's hard to worry about 2100 for most of these countries in terms of just the governance structures and planning and investing for that far into the future. Human influence on types of extreme weather events. This is just to emphasize some of the points. If you look at kind of the weather events like heat, rain, flood, drought, storm, cold and snow, wildfires, ocean heat waves, atmosphere, ecosystem function, river flows, and so on, and look at human influences in terms of more severe or more likely to occur, and less severe and less likely to occur, no discernible human influence, and insufficient data or inconclusive. It shows that number of studies for each type of extreme event that fall in each category varies this way. So heat waves, more severe, more likely to occur in terms of human influence, very clear here. Almost all of them say that, except few regions where there is not enough data, which means we definitely need to ramp up the efforts of monitoring this data. The limitation is quite severe, but there are places where there are still no discernible influences, but one has to be careful in terms of asking the question. The probability of heat wave may not be changed, but the intensity of the heat wave and the duration of the heat wave may be changed by human influence. So those sorts of details are important as well. Rain and flood, droughts, again significant human influences, and then you have others like storms, wildfires, and oceans. So obviously human influence is now quite widespread in all regions of the planet, including the polar regions, as we have seen in the IPCC AR6 discussion. Heat-related mortality rate attributable to human-induced climate change over 1991 to 2018. You can see that there are many countries where attribution has been done, and human induced climate change is blamed, especially over here where mortality rates tend to be high with heat waves compared to these regions. There is blank here doesn't mean that there are no related mortality rates attributable to human-induced climate change. It's just that they may not be done, or studies may not be published. In the IPCC AR6 discussion, I showed these hot temperature extremes over land. Once in a 10-year event over 1850 to 1900, the frequency has gone from being once per year to now, with 1 degree C warming, likely to occur 2.8 times with some uncertainty. And with the 1 degree C warming, the heat waves are now 1.2 degrees C hotter, and with future global warming levels of 1.5, 2 and 4 degrees centigrade, once in 10-year events are likely to occur 4.1 times, 5.6 times and 9.4 times respectively, with increased intensities as well. So whatever the uncertainties, we have to prepare for these and better plan for those. And the best adaptation strategy is the early warning systems. So type of preparation possible for heat waves around the world is based on predictability of temperature. So you can see places where seasonal preparedness is possible based on predictability of temperature. Short-term forecasts are possible. These are hot spots for heat waves, for example, Pakistan, Northwest India, for example. And the dark regions are where both seasonal preparedness and short-term forecasts are possible. So I have talked about these horizons of forecasts from 1 to 3 days, short-term, medium-term, 3 to 10 days, extended range weeks 2 to 4, and seasonal timescales. You can go and look at that in my course under S2S predictions. But obviously this is encouraging, remembering of course that model skills are still good at large scales. So we have to find ways of downscaling those forecasts to the neighborhood scales where vulnerabilities matter. So the exposure is not uniform and vulnerabilities are not uniform at all. So risk is not uniform either. Humanitarians do not need to create a new system to deal with extreme heat, but they do need to think and act differently in at least 5 key areas. Build the evidence base on the impacts of extreme heat and provide early actionable information to decision makers. Comes down to having reliable early warning systems. Best adaptation tool we can build right now. Support preparedness and expand anticipatory action for heat waves and compound disasters where heat waves hit on top of a drought that is going on, for example, creating all sorts of additional problems and could be disease outbreaks, mosquito population, etc., etc. Explore new and more sustainable ways of financing local action. These are kind of broad statements, but still very useful. Implementing them, of course, will take a lot of coordination at local, state, national, international levels. Adapt humanitarian response to accelerating extreme heat, obviously. Deepen engagement across the development, humanitarian and climate spheres. Right now they can be operating independently. Development keeps going, just focusing on economic growth, GDP growth rates and so on, without worrying about humanitarian aspects or climate aspects. So all these things have to come together. Countries like China and India have no choice but to focus a lot on development, but can they do it in a way where things like heat waves and exposure and vulnerabilities are not severely exacerbated? So even increased income, if it comes with highly increased vulnerability, then you may be just doing a trade that's not very good in the long run in terms of increasing income, but not worrying about impending climate impacts, especially heat waves. Okay, so I'll leave it here. The report is very useful. You can read, and I have other related podcasts that you can follow up on as well. Okay.